Hey guys, I'm starting on the very back. I just wanted to map out what we're doing right now. What kind of variables have we been worried about? What kind of ideas, what kind of topics are we worried about? So we have horizontal and vertical what? So we have a distance idea, or we've called it now that it's a vector, a displacement. And we have, what is it when I move that displacement in a period of time? So we have velocities. And is my velocity always going to stay the same? No. So I have a velocity initial and then I have a velocity final. And because I'm changing my velocities, what do we know we also have? We have a change in speed, which is acceleration. And then we have to do that in a period of time. So those are the 5 variables that I'm worried about. A lot of times displacement, we give the letter x. And so we have a vertical x and a horizontal x. Some people call that vertical xy, but I will just say delta x in the y direction. Okay? What is another way of saying that? The change in... If it's the change in placement in the vertical, what's another way of saying? Height. Okay? So that's relative to height. And then we said that the delta x in the x direction is relative to... What's the new vocabulary word? Starts with an R. Range. Okay. So we have a height and a range. And what else do we know in any of our problems here on Earth? Gravity is... localized gravity is g. For us, that's 9.8 meters per second squared in the downward direction. So I threw a negative in there. It only happens in the vertical, right? Yes. So when I make my chart, this acceleration is 0. If there's no acceleration, what else could you say? Constant velocity. Good. Constant velocity means that when I draw my lines, VI and VF, they're the same. That's one box for both of them, right? And nothing crosses. We have VI, VF, except for, what's the one idea that can cross vertical and horizontally? Because it's neither, is time. So these are the same. And these are the same. Right? And because we have a changing speed and an acceleration, we said we no longer use our middle school definition. What are our equations for our variables to convert from variables to variables? We said x equals right, VOT plus 1/2 AT squared. We have the definition of acceleration. And if you combined both of them, so we have V final equals V initial plus AT. And then if we combined both of them and we substituted it in, we have VF squared equals VI squared plus 2AX. The only one that's valid in the horizontal, well, A, if you plug in 0 for any of these A's, well, of course, VF equals VI plus 0. That this, if this A is 0, the VF is the VI. If A is a 0, the VF squared is the VI squared. But this first equation works in horizontal, that x in the x direction will equal Vx times t. We don't need the 1/2 AT squared because that would be 0, right? There is no change in speed. So this is the middle school equation, that distance over time is your speed, right? So there's only one equation that I need in the horizontal. There's the 3 that I would use for the vertical to go between any of these, almost any of these. All right, so as a general rule of thumb, this is the way I think. The only bridge between the two is, between vertical and horizontal is time. Okay? That becomes where we need to find the time if we're trying to get between the two. That's just a So sample 3 is kind of a continuation of problem 2. Now the cannon is placed on a platform 2 meters high. The cannon is launched at 15 meters per second at an angle of 35 degrees. How far does the cannonball travel horizontally from the base of the platform? We've done a similar problem, but we had a lot of symmetry because we were dealing with a cannonball that's launched at 15 meters per second at an angle of 35 from flat ground up and back down. Now we're on a platform. What I would pull from this is that I'm going to be using the same exact velocity initial we had yesterday in both components of it. Right, we still have the same launch speed, 15 cosine 35, 15 sine 35. So my illustration is a little bit different. I've got my cannon. I'm just going to put a ball here that's getting launched, and we're going to give it 15 meters per second at 35 degrees. It's going to go up, and it's going to land below where it starts, right? So that's its trajectory, its planned pathway. When does it, is it a vertical or a horizontal issue when it hits the ground? Vertical, right? It's not hitting a wall. The problem stops when it hits the ground. That's a vertical issue because the ground is below somewhere. It's an up and down issue. So if we place the cannon 2 meters high, that's my change in x in the y direction. And we're going to throw a negative sign in front of there because it's going down. We have a starting speed. The initial in the y direction is 15 sine 35, which we saw last problem 8.6. If you need to throw that in the calculator, make sure it's in degree mode. 15 sine 35, enter. And then we have something else. We have one other thing. Acceleration due to gravity is negative 9.8 meters per second squared. Many of you are smart enough, bright enough, smarter than me. And the reason that means you're more studied than me, because you might know the quadratic formula. If you wanted to, you could say x equals VIT plus 1/2 AT squared. And you would solve for t with the quadratic formula, I think. I'm too dumb for that. And so what I've decided is that maybe I could say VF squared equals VI squared plus 2AX. And this is actually using the quadratic formula. If you rearrange things, it's the same exact math steps you would take. I just don't know, have it memorized. I'm just, haven't had math in 27 years. I would say 8.6 squared plus 2 times negative 9.8 times negative 2. So my negatives cancel out, right? And then that would equal VF squared. So even though you get a really big number, take the square root of it. And my velocity final equaled 10.64. I'm pulling that out of my memory. And it's negative 10.64 meters per second. You're like, Mr. Kwan, I didn't get a negative when I took the square root of that. I got a positive 10.64. Anybody get a positive? Everybody got a positive 10.64. What did you really get, though, in math land? When you take the square root of both sides, you get a plus or minus 10.64. And we know that right at this moment, when it impacts the ground, it's going down, okay? So we're going to just say, hey, look, the plus or minus, we actually know it's the minus. It's plus on this side of the parabola, math-wise, but we never actually flew that path right there before it even starts, right? We just know that our coordinates are negative 10.64 when it hits the ground. And that's important because what we're going to do is, instead of getting a negative time, we're going to say VF equals VI plus AT. And so when we plug it in, we have negative 10.64 equals our starting speed, 8.6, plus negative 9.8 times t. 19.24 equals 9.8 t. I already canceled out my negatives. If you want me to put them in, it's just I'm going to have one on each side. Here, I'll do it just in case. Just so you don't get lost. I do have negatives there. I just canceled them out. What happens here? T equals seconds. How far does the cannonball travel horizontally? That's a time. This is a time. That's not how far it travels. This is our bridge, though, right? We wouldn't be able to get to our horizontal component without that. So if we have a VIY, I bet you we have a VIX. You could do 15 cosine 35, or you could look at the number from the last problem we did. What was it? 12.29. I should write down my work still. Sorry, I'm just going back to show my work. I did 15 cosine 35 equals 12.29 meters per second. And we only have one equation in the x direction. What is it? Right, and the a is 0, so we just really have v times t. So we have 12.29, 12-ish, times 2-ish equals, that one's a little bit bigger, that one's a little bit smaller, so equals about 24. 24 meters? Meters per second? Meters. So that's its horizontal range, 24 meters. It's a lot of steps because I don't know quadratic formula.